Okay, so what we are doing today is a review on radicals, factoring, and systems of equations. All of this stuff should be a review from last year in Algebra 1. I will also post links to Mrs. Battis's review on radicals and systems of equations. So if you feel like you need to have it broken down a little bit more, you can also view those videos. Okay, so to start, we're going to talk about radicals. So first we want to figure out how to simplify these. Now, if I look at the square root of 9, we know that 9 is broken into 3 times 3. And so we have a pair, right? Because if we have a square root, we can think of the index as a 2. Since I have two 3's, the square root is just 3. Now, square root of 45, we know if we break it down is 9 times 5, so that gives us 3 radical 5. Now take a moment, pause the video, and think about the square root of 54 and how you could do that one. Okay, so the square root of 54 we know is broken down into 9 times 6. Now this one we know is the square root of 3, square root of 9, is 3, and we can do the square root of 6. Now even though there's a 3 there, we still have to keep the square root of 6 inside. Okay, now when we multiply them, we can actually combine them and smush them together into one radical and have it be the square root of 18. Now this allows us to see that we have 9 and 2, so we would have the square root of 9, which is 3, and then the square root of 2 is still there. Now sometimes, like in this next problem, that's a little bit trickier. Okay, so multiplying 10 times 15 gives us 150, and that's harder for me to think about. So I can actually smush it into one big radical and have 10 times 15. Now I can look at this. Okay, so 10 is made up of 2 and 5. 15 is made up of 5 and 2. Now I have a pair of 5's right here, so I know I can take one 5 out, and then, this is 5 and 3. We know that 2 times 3 is 6, so we have the square root of 6. Dividing and rationalizing, very similar. All right, we can actually take them and smush it under one big radical, so 10 over 2. We know that that's 5, so we just have the square root of 5. When we have something like this, multiplying it like that isn't going to do us any good, but let's simplify a little bit. I know that 12 is made up of 4 and 3. Remember to always look for those perfect square factors. So that gives me 2 radical 3 over the square root of 15. There's no way for me to simplify 15 as 3 and 5 are both prime. Now, when we talk about rationalizing, okay, we multiply by 1. Now this time, 1 is going to look like the square root of 15 over the square root of 15. Okay, so when I multiply this, I know 15 is made up of 5 and 3. So if we go down here, right, we see 2 square root of 3 times 15, because remember, we can smush those together. All over. Now 15 times 15 underneath the square root will become just 15. Now, like we said earlier, 15 is 5 and 3. I see that I have a pair of 3's, so I can take one of those out. 2 times 3 is 6. Square root of 15 all over 15, and that's your final answer. All right, adding and subtracting. Adding and subtracting radicals must have the same exact radical. So square root of 12 and square root of 18, let's first figure out how we can simplify these. I know that 12 is made up of 4 and 3. So that means I have 2 square root of 3 plus 18 we know is made up of 9 and 2. Remember, always look for those perfect squares. So 3 radical 2. Now we can think of this as the same thing as 2x plus 3y. We know from Algebra 1 that we can't actually combine those. So that means that this is our final answer. We cannot combine the square root of 3 or the square root of 2. So we have to leave it just like that. Now this one's a little bit different. We look at it in terms of the square root of 3 radical 2. That one's already done for us, so let's just keep that there. 24 we know is made up of 4 and 6. So I have plus 2 square root of 6, remember the square root of 4 is 2, plus 8, we know is made up of 4 and 2, so 2 square root of 2. Now if we think about this in terms of x and y's, we can think about this as 3x plus 2y plus 2x. And you know to combine the ones that have x's. So in this case, we combine the radical 2's. So that's 5 radical 2 plus 2 radical 6. Now there's nothing else I can do here, so that is my final answer. Now factoring, this is something that we've seen before. So when we factor, the first thing we always look for is our greatest common factor. So in this first one, 15x squared minus 3x, I see, okay, what do I have in both? Well, in the 15 and 3, I can pull out a 3. The x squared and x, I know I can take an x out. So in reality, what we're really doing is dividing each of these terms by 3x. So 15x squared divided by 3x leaves me with 5x, and negative 3x over 3x leaves me with minus 1. Don't just think that that miraculously goes away and becomes a 0. We still remember x over x, 2 over 2, they all equal 1. So this is my final answer. When we look at the second one, x squared plus 10x plus 16, we know when we factor we're going to end up getting 2 sets of parentheses. We want to look for what's going to give us x squared. Now I know that's going to have to be x and x. Now 16, let's think of our factors. We have 1 and 16, 2 and 8, 4 and 4. When I look at these, I know that both of them have to be positive since we're adding to a positive here. And then I have to look and see which ones of these add up to 10. Well, 4 plus 4 is 8, so that's not it. 1 and 16 adds up to 17, so it has to be 2 and 8. Now, it doesn't matter the order, but they just have to go in the second spot. So this is your final answer. When we look at 2x squared plus x minus 10, this one's a little different. We know we're going to have 2 sets of parentheses still, but this time we know it has the 2x squared, so that means 2x has to go in one spot, x has to go in the other. When we have this 10, again, so now we have to look at 10. Now I know that I have factors of negative 10, so I'm either going to have negative 10 and positive 1, positive 10 and negative 1, 5 and negative 2, or negative 5 and positive 2. Now the 2x is going to make a difference. We can't just look and see which ones add up to what. So I know that if I put the negative 10 here, that's not going to help me because I'm going to end up with negative 20. So that one has to go away. So we know that this one's not going to be it. Chances are neither will this one because positive 20 is still pretty big. So if I look at 5 and negative 2, let's say I put the negative 2 here and then the positive 5 here. Well, this here, if I check it, gives me 5x. This one gives me negative 4x. And when I add them up, I get x, which is exactly what I need. So that means my final answer is 2x plus 5 and x minus 2. So if we look at systems of equations, what do systems of equations give us? What do they actually help us understand about two different equations? Take a moment, pause the video, and write in your notes what you think the answers to these questions are. Now, when we look at systems of equations, they ultimately give us an answer. They give us an x and a y coordinate. This coordinate is very important because this coordinate is true for both of the equations. This x and y value will fit into both of the equations and make them both true. So this helps us understand the two equations and where they intersect. They help us understand the value, where they are both true. All right, so write what you think, if you were correct, if you were wrong, and why you think that you kind of had a misconception there. So we have three ways to solve systems of equations. I'm sure you've learned these before. The first one is graphing. The second one is by substitution, and then the last one is by elimination. Elimination could also be addition, depending on your teacher as well. So when we solve by substitution, the best way to solve for substitution is to have something like y equals. All right, you want a single variable. It could be x equals. You want a single variable all alone, because this is where you substitute. So what jumps out at me is this second equation, 3x plus y equals 18. I see that I have y all by itself. So that means I want to use that to my advantage. So I'm going to solve for y. To do that, I know I have to subtract 3x from both sides. So I end up getting y equals negative 3x plus 18. Now, if we look at the top equation, I have a y right here. So I know what y equals, right? It's this guy right here. So we are going to substitute that in for that y. So I'm going to have 4x minus 2 times, remember, use parentheses. The parentheses are very important since we're just replacing the y. We're not replacing the negative 2, just the y. And remember, the symbol in between those two is multiplication. So the y equals negative 3x plus 18, and that still equals negative 1. Now we solve this just like an algebra problem. We distribute the negative 2 to both terms, so I'm left with 4x plus 6x minus 36 equals 1. I combine like terms and get 10x equals 37. Oh, no, it's a negative 1, so it should be 35. And so that gives me x equals 3.5. Now, fractions can sometimes be a little bit easier, and I like to use fractions, so I'm going to say x equals 7/2. All right, so we are going to use that. Now that I have that x equals 7/2, we need to find y. So I go back here and plug it in for the x. Why do all the hard work again and have to isolate y when we've already done the work? So I now have y equals negative 3 times 7/2 plus 18. Don't forget to use those parentheses around the 7/2 because we replaced the x with the 7/2. So now I see that I have negative 21/2 plus, and I notice here that I'm going to need 2 in the denominator, so I'm just going to go ahead and do that right now. So I'm going to have 36 in the numerator. That's going to leave me with y equals 15/2. Now your final answer might look like, oh, I have x equals 7/2 and y equals 15/2. But remember, when we're talking about systems, we always want to have an ordered pair. So I have 7/2 and 15/2. That is my final answer. Keep in mind, we want that xy value. Now, solving by elimination is a little bit different. This is when solving for a particular variable, x or y, looks like it would be a little trickier. Now, what we want to do here is we want to cancel or remove one of the variables. So instead of trying to solve for y, I want to get rid of y. Now, I notice in the numerator, or the first equation, I have negative 8y. But in the bottom equation, I have negative 2y. Well, I know that I can multiply this entire equation by negative 4 in order to make that negative 2y a positive 8y. And you'll see why we do that in a minute. So 2x minus 8y equals 16. Now in the bottom, you have to distribute that negative 4 to every single term. So that gives me 12x plus 8y equals positive 40. Now what we want to do is we want to add them up. So when I go to add them up, I see, okay, 2x plus 12x is 14x. Negative 8y plus 8y, well, look at that, it goes away. And that's going to equal 56. So now I have a really simple equation. All I have to do is divide both sides by 14, and I see that x equals 4. So now that you have x, now you're going to use substitution to figure out y. You can use whatever equation you want. I choose to use the top one, but you can use the bottom one. You'll still get the same answer. X equals 4. You're going to plug that guy in right here. So 2 times 4 minus 8y equals 16. So 8 minus 8y equals 16, negative 8y equals 8. So y equals negative 1. So I now have x and y. Am I done? No. I need to make sure I write that in xy form. So that's 4, comma, negative 1. Keep in mind, if you were to plug in that 4 and negative 1 in either of the x or the y in either of the equations, and you solve it out, you're going to get 16 and negative 10. That's because this is a system of equations, and this point right here at 4 and negative 1 is true for both. This is where they intersect. Last but not least, we have this problem, and this problem looks a little complicated. When we do this, we want to make sure that we get our equations in the form of ax plus by equals c. This is called standard form. Now, when everything's in standard form, it's a little bit easier to figure out if you should solve by elimination or if you should solve by substitution or perhaps by graphing. We'll talk about solving them by graphing a little bit later in the year. So why don't you take a moment and solve this either by substitution or by elimination, and then we can see how you did. All right, so let's see. I'm going to start solving this and put it in standard form first. So for my top equation, I have 6x plus 3y equals negative 24. And in the bottom, I have 7x minus 6y equals 10. Well, you could solve this by elimination, by substitution, but I think elimination looks easier. And that's because I can multiply the numerator by 2 to cancel out those y's. So I'm going to have 12x plus 6y equals negative 48. I'm going to have 7x minus 6y, and that's going to equal 10. We add them up. The y's better cancel. I'm left with 19x equals negative 38. When I divide by 19, I better get that x equals negative 2. From here, I don't want to go back up to the messy equation that's written in black. I just want to go back up to the top. So I'm going to choose to use this one. So I'm going to have 6 times negative 2 plus 3y equals negative 24. Negative 12 plus 3y equals negative 24. We're going to add the 12 over. 3y equals negative 12. Divide by 3. Y equals negative 4. How'd you do? Are you done? Nope. We have to make sure we write it as negative 2, negative 4. And that is your final answer.